Hello and welcome to Advanced Algebra. In yesterday's lecture, we looked at three types of horizontal transformation of a function, of a graph of a function. In this lecture, we're going to combine these three types of transformation. Let's recall the three types of transformation first. So here are the three types of horizontal transformation we've looked at yesterday. A horizontal translation. So if you have the graph of a function like this one right here of y equals f of x, a horizontal translation will look like this. Y equals f of x minus h. If h is positive, the graph will move right. And if this is for h positive, and if h is negative, the graph will move left. This is for h negative, okay? So this is the first type of transformation. The second type of transformation we've seen was a horizontal dilation or compression. So they look like this on the function, f of s times x. A compression will look like this. For example, let me divide by 2 right here about, right? You take an x length right here and you divide it by 2, okay? So that would be a compression by a factor of 2. A dilation would look, so now I'm going to take an x length and I'm going to multiply this by 2. A dilation will look like this. You stretch the graph, okay? So these are two types of dilation compression. And finally, the last type of transformation was a reflection through the x-axis. So this is y equals f of negative x. A reflection through the x-axis basically looks like this. This branch would go right here, and this branch would go like that. Something like this, right? Sorry for the symmetry, it's not very good, but you see what I mean. Okay, so now we want to combine these transformation. What does it mean? Now we want to look at the graph of the function y equals f of negative s times x minus h. Okay, how do we do that? Which one do we do first? Does the order matter actually? Can I just do the translation first and then the compression dilation, or compression dilation first and then the translation? Does it matter? Yes, it does. Let's try to understand the motivation for an order. Let's do that through an example. So in red right here, you have the graph of a function that I call f, y equals f of x. And I want to graph the function y equals f of 2x minus 2. So I do see a horizontal translation right here, 2 units to the right. And I do see a horizontal compression right here. You remember s is above 1, that's a compression. On the x, it's always counterintuitive. The minus right here would want to make you move left, but you have to move right. The 2 right here would want to make you multiply the x by 2, but actually you divide them by 2. It's a compression. All right, which one do we do first? Well, we have a choice. We can do y equals f of x, 2, y equals f of x minus 2, 2, y equals f of 2x minus 2. Okay, so first translation, second compression. Or we could do y equals f of x, 2, y equals f of 2x. Let's dilate first. And then let's translate this 2 units to the left. 2x minus 2. I meant right. Okay, 2 units to the right, of course. Okay, well, let me show you the difference between these two types of transformation. So let's do it step by step. I am going to do this one first. So the first graph tells you to move 2 units to the left. So I'm going to take each point. Why am I saying left all the time? It's 2 units to the right, sorry. So I'm going to take each point and move them to the right. So here we go. This one right here. 2 to the right, 2 to the right, 2 to the right, 2 to the right. Here we go. That's y equals f of x minus 2 right here. F of x minus 2. And finally, I'm going to do my compression. I'm going to divide all the x length by 2. So the x length right here is 2, so 2 divided by 2, 1. The x length right here is 3 divided by 2, 1.5. Right here the x length is 6 divided by 2, 3. 11 right here, right? 11 divided by 2, 5.5. You don't touch the y, right? It's the same y. And finally, the last one, I have 16, 17, 18 divided by 2, 9 right here. So this is a graph I find when I follow the first sequence, this one right here. Okay? Let me erase the intermediate graph, and I want to keep the final graph, because now I'm going to be looking at the second sequence, this one. So let's go back on the original graph, the red one. First, what do? You divide all the x length by 2. So the x coordinate right here is 0 divided by 2, 0. Right here the x coordinate is 1 divided by 2 is 0.5. Right here the x coordinate is 4 divided by 2, 2. Right here the x coordinate is 9 divided by 2, 4.5. And finally 16 divided by 2, 8 right here. So this is my first transformation right here. It's very close to the other, right? Like that. And then I move 2 to the right. So this one, 2 to the right, is right here. This one, 0.5, 2 to the right, is 2.5. This one, 2 to the right, is 4 right here on top of it. This one was 4.5, 2 to the right is 6.5 right here. And then this one, 2 to the right, is here. So the two graphs are actually not too far from each other, right? But they're not the same, right? Let me erase this one right here. They're not the same at all. Which one is correct? Is this the first transformation or the second? Well, it's not the second. It's the first. There is an order. You have to respect it. The translation is always first. The dilation, compression, comes after. Let me show you what you need to remember. Here we go. Right here, I wrote the sequence of transformation. This is y, okay? This is like y, g of x. I call it g, it's another function, right? It's just the same as y. I wrote the order of the sequence of transformation. First is a translation. Second is a dilation compression. Third is the reflection, if you have a negative sign, right? If you don't have a negative sign, there is no third transformation. All right? Okay, you need to remember the sequence. Look, it goes from right to left. It's not too difficult to remember. Let me show you how it works. I'm going to let you do example number 1. Please follow me on example number 2. After I'm done with 2, then try 1. All right. Here's in blue the graph of a function that I call f. I want to graph the function f of negative 3x plus 6. So the first thing I need to do, you know what it is, right? It's the translation. So it is y equals f of x plus 6. All right, so plus 6, remember, counterintuitive. Plus makes me want to move right. I'm adding 6. I want to move this way, but it's counterintuitive on the x. It moves left. 6 units to the left. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Don't lose track here. 6. And finally the last one. 1, 2, 3, 4, 5, 6. Okay, let's connect with straight-ish line. Here we go. All right, that's my translation. Second, what do I have? Well, second, I have y equals f of 3x plus 6. This is a compression by a factor of 3. So I have to compress the black graph by a factor of 3. Alright, so let's read the coordinate here. What's the coordinate of this point? 15, negative 15. Negative 15 divided by 3, negative 5. 1, 2, 3, 4, 5. Right here. Right, I'm dividing by 3. Right, you take this x length right here and you divide it by 3. 3, 2 right here. Right, I take 1/3 of it. That's what I do. I divide it by 3. So this point is going to go right here. Alright, this x length is negative 9. Negative 9 divided by 3, negative 3. So I'm going back to the original point right here, negative 3. This x length right here is negative 3 divided by 3, negative 1. So this is really getting crowded here, okay? Let me actually start drawing my segment right here, right here. 0 right here, this one right here was at 0 divided by 3, it's still 0. And finally, this one is 6 divided by 3 is 2. Okay, so this is really, really crowded. I hope you can follow me, but you see the green one here. I'm going to erase the black, but before I do, make sure you understand that the green one is a shrunken version of the black one. I divided all the x length by 3. So do it carefully, don't make a mistake. Alright, now what do I need to do now? Let me erase right here. Here we go. Now I need to reflect. That's the last one. I need to reflect. So let me pick up my red pen and let's reflect. So plus 2 would go to minus 2. 0 would stay at 0. Here's a reflection of the first segment right here. Negative 1 would go to plus 1 right here. Right here. That's this one. Then we have negative 3 would go to plus 3 like this. And finally, that was a negative 5 would go to plus 5, 3 to 5 right here. Here we go. The red graph is a mirror image of the green one through the y-axis. It's a little bit encumbered here, but I hope it's clear enough. Alright, let's move on to the next example. Alright, so this time I'm going to do 3 and you're going to do 4. Example number 3. So again, let's start with the plus 4. Plus 4, don't forget, counterintuitive, I'm going to move left 4 units. This point would go 1, 2, 3, 4 right here. This point would go right here. This point would go right at 0, 4 units. This is 9, it would go at 5. 1, 2, 3, 4 right here. It should be 5. And finally this one, 1, 2, 3, 4 right here. So this is 4 units to the right. Now what do I do? Now this is x divided by 2. So I would like to divide my x's by 2, but actually, you know, I'm going to have to multiply, right? Okay, so let's stretch. This negative 4 times 2 is negative 8. 5, 6, 7, 8 right here. This negative 3 times 2 is negative 6 right here. This 0 times 2 is 0. Okay, now what about this one? This was 5. 5 times 2 is 10. 6, 7, 8, 9, 10 right here. And I don't think I'm going to be able to grab this one because this was 12, I think. Yes, this was 12 times 2, 24. I don't have it here. But you see what happened? The graph gets elongated, stretch like that right here. And finally, you reflect it through the y-axis. So let's reflect it through the y-axis. We had minus 8 that will become a plus 8. 6, 7, 8 right here. We had a negative 6, it would become plus 6. 3 and 3, 6 right here. 0 reflected through the y-axis stay at 0. And this one right here was 10, and that would become negative 10. So I think it's maybe this one right here. Maybe this one or this one of the two. Anyway, I'm not gonna count. You would have to do it precisely. Here we go. That's reflected of the green graph. Okay? All right, this is a graph shifting of some graph. Let's do graph shifting of some points now. Please do example number 4. Let me show you 2 types of examples and we're done with this video. All right, I'm gonna do 5 and you're gonna do 6. So in this case, I'm not giving you a graph, I'm giving you a point on the graph of a function y equals f of x. And I'm asking you, find a point on this graph right here. So remember what to do, right? You take this point and what do you do to it? First, you translate it. Plus 5 means 5 units to the left. So you have to subtract 5 to the x, right? So this would go to -7 and then -5, and you don't change the y, of course. So the point that you're getting right here is -12, -6, 5 units to the left. Next, what do you do right here? Well, right here, it's x divided by 2, so you have to multiply the x by 2, right? Just the x, not the y. So you take -12 and you multiply this by 2, and you don't change the y right here. So this point is actually -24, -6. And finally, what do? You reflect across the y-axis. So a reflection across the y, if a point is right here, how do you reflect across the y-axis? Well, x becomes -x. You flip the sign in front of the x. And so the final point is 24, -6. That's what I have when I graph shift this to that right here. Okay, last example. Do number 6, I'm gonna do number 7, and you're gonna do number 8. Okay, number 7, my point is 0, 2. So how do I transform 0, 2 on this graph to find a point on this graph? Alright, so what do you do first to 0, 2? Well, first you gotta do the -6, the horizontal translation. -6, you don't subtract, you're gonna add, you're gonna move right. So you're going to add 6 units to your x right here with the -6, right? Don't touch the y. So the point is 6, 2. Second, what do? 3x. 3x, you remember, you don't multiply the x. It's counterintuitive. You will compress, you will divide all the x's by 3. So this point goes to 6 divided by 3, 2, right here. And so it is, and actually that's my final point, right? I do not have a reflection here. So it is 2, 2. That's my final point. There is no reflection across the y-axis. That's it. Thank you for watching.